When upgrading a 100 amp service to 200 amps and facing space constraints, there are several options to consider for distributing power to both the house and the garage. One option is to use a 200 amps meter base with dual load side lugs. This provides dedicated load side terminals for both the house and garage panels, which eliminates the need for a separate subpanel for the garage and simplifies wiring, reducing the risk of overloading. However, this requires a wider meter base, which may not be available in limited spaces, and it can be more expensive than other options. Another option is split paneling, which allows you to use a standard 200 amps panel with 40 spaces and provides separate compartments for the house and garage circuits. It can be more cost effective than a dual load side meter base. On the other hand, this requires careful planning and labeling to ensure proper overcurrent protection device placement, and can be more difficult to access and work on if space is limited. A third option is to install a subpanel in the garage. This provides a standalone solution for the garage circuits, allowing you to install a smaller panel in the garage, saving space, and can be more convenient for accessing and working on garage circuits. However, this requires additional wiring and materials, and can be more expensive than splitting the panel. When choosing the best option, consider the available space, budget, and ease of installation and maintenance. For a limited space scenario, a 200 amps meter base with dual load side lugs is often the most efficient and safest solution for splitting the service to the house and garage. If choosing the split paneling option, ensure that you provide very clear instructions for the homeowner. Explain the concept of only installing overcurrent protection devices on one side of the panel. Stress the importance of never installing an overcurrent protection device on both sides of the panel in this setup. This is paramount for maintaining electrical safety and preventing potential hazards. Explain that the panel is specifically configured to distribute power in a balanced manner, and that deviating from this configuration could lead to imbalances and potential overloads. Provide a detailed diagram illustrating the correct overcurrent protection device placement. This diagram should clearly show which side of the panel is designated for the house circuits and which side is for the garage circuits. Use color coding or labels to further distinguish between the two sections. Reinforce the importance of adhering to this diagram during any future electrical work. Explain the potential consequences of incorrect overcurrent protection device placement. Emphasize the risks of overloading circuits, causing breakers to trip frequently and potentially damaging electrical equipment. Clearly state that improper overcurrent protection device placement can create a fire hazard and endanger the safety of the occupants. Offer to be available for future consultations or questions regarding the electrical system. Provide your contact information and encourage the homeowner to reach out if they have any uncertainties or need clarification on any aspect of the electrical setup. Doing so shows that you are committed to ensuring their safety and satisfaction. Consider providing a written document outlining all the key information discussed. This document should include a summary of the electrical system configuration, the overcurrent protection device placement diagram, and your contact information. Having a written record will serve as a valuable reference for the homeowner in the future. Explain the concept of balance loads and how they relate to the electrical panel configuration. Emphasize the importance of distributing electrical loads evenly across both sides of the panel to prevent imbalances and ensure efficient operation. Provide examples of how to identify and correct load imbalances. Explain how to use a clamp meter to measure the current on each leg of the service and identify any significant differences. Discuss strategies for redistributing circuits or appliances to achieve a more balanced load. Explain the importance of regularly inspecting the electrical panel for any signs of damage or deterioration. Instruct the homeowner to look for things such as loose wiring, corroded connections, or evidence of overheating. Emphasize the need to contact a qualified electrician immediately if any problems are detected. Explain the function of overcurrent protection devices, such as circuit breakers and fuses. Describe how these devices protect the electrical system from overloads and short circuits. Emphasize the importance of never replacing a breaker or fuse with one of a higher amperage rating. Explain the potential consequences of doing so, including the risk of fire. Encourage the homeowner to familiarize themselves with the location of the main service disconnect and how to shut off power to the entire house in case of an emergency. Provide clear instructions on how to safely operate the disconnect switch. Emphasize the importance of keeping the area around the electrical panel clear and accessible at all times. Remind the homeowner not to store any flammable materials near the panel. Also, discuss the importance of grounding and bonding in the electrical system. Explain how grounding and bonding provide a path for fault current to flow back to the source, allowing overcurrent protection devices to trip and clear the fault. Emphasize the need to maintain proper grounding and bonding throughout the electrical system to ensure safety. Describe the different types of grounding and bonding conductors used in residential electrical systems, such as the grounding electrode conductor, equipment grounding conductors, and bonding jumpers. Explain how these conductors are connected to the grounding electrode system and to various metal components throughout the house. Remind the homeowner that electrical work can be dangerous and should only be performed by qualified individuals. Encourage them to always hire a licensed electrician for any electrical repairs, installations, or modifications. Advise them to never attempt to work on electrical systems themselves unless they have the necessary training and experience. Suggest scheduling a periodic electrical safety inspection with a qualified electrician. These inspections can help identify potential hazards and ensure that the electrical system is in good working order. Explain the benefits of having a professional electrician assess the electrical system on a regular basis. Discuss the importance of surge protection to protect sensitive electronic equipment from voltage spikes. Explain how surge protectors work and how they should be installed. Recommend using surge protectors at both the service entrance and at individual outlets to provide comprehensive protection. Describe the different types of surge protectors available, such as whole house surge protectors and plug-in surge protectors. Explain the importance of properly grounding surge protectors to ensure they function effectively. Also, discuss the importance of arc fault circuit interrupters or arc fault circuit interrupter protection in preventing electrical fires. Explain how arc fault circuit interrupters work and where they are required by code. Describe the different types of arc fault circuit interrupters available, such as circuit breaker arc fault circuit interrupters and outlet arc fault circuit interrupters. Explain the importance of testing arc fault circuit interrupters regularly to ensure they are functioning properly. Remind the homeowner to test their arc fault circuit interrupters monthly and to replace them if they fail the test. Ensure that the homeowner is informed about the proper use of the load side terminals to prevent overloading. Provide them with a load calculation worksheet to help them determine the appropriate size and number of circuits for their house and garage. Explain how to use the load calculation worksheet to estimate the total electrical load and ensure that it does not exceed the capacity of the service. Advise them to consult with a qualified electrician if they have any questions or concerns about load calculations. If utilizing a subpanel in the garage, discuss the importance of properly sizing the feeder conductors and overcurrent protection for the subpanel. Explain how to calculate the appropriate size of the feeder conductors based on the anticipated load of the garage. Emphasize the need to use conductors that are rated for the appropriate ampacity and voltage. Describe the different types of conductors that can be used for feeder circuits, such as copper and aluminum conductors. Explain the importance of using the correct size and type of overcurrent protection for the subpanel to protect the feeder conductors from overloads and short circuits. Remind the homeowner that the subpanel should be properly grounded and bonded to ensure safety. Explain the requirements for grounding and bonding subpanels, including the use of a grounding electrode conductor and equipment grounding conductors. Emphasize the need to follow all applicable electrical codes and regulations when installing a subpanel. Advise the homeowner to obtain the necessary permits and inspections to ensure that the installation is done safely and correctly. Explain the importance of labeling all circuits in the electrical panel to identify their purpose. Describe how to create clear and accurate labels for each circuit breaker or fuse. Emphasize the need to update the labels whenever any changes are made to the electrical system. Remind the homeowner to keep a record of all electrical work that has been performed on the house, including permits, inspections, and wiring diagrams. This record will be helpful for future maintenance and repairs. Finally, advise the homeowner to contact a qualified electrician if they have any questions or concerns about their electrical system. Explain that electrical work can be dangerous and should only be performed by qualified individuals. By following these steps, you can ensure that the homeowner understands the importance of proper overcurrent protection device placement and the potential consequences of making any mistakes. This will help to create a safer electrical system and prevent potential hazards. Explain the concept of selective coordination and its importance in electrical systems. Selective coordination is a design practice that ensures that only the overcurrent protection device closest to a fault opens, minimizing the impact of the fault on the rest of the system. Describe the different methods for achieving selective coordination, such as using current-limiting fuses or circuit breakers with adjustable trip settings. Emphasize the importance of coordinating the overcurrent protection devices in the main panel and any subpanels to ensure that they work together effectively. Explain the potential consequences of not having selective coordination, such as nuisance tripping of breakers or damage to equipment. Discuss the importance of voltage drop calculations in electrical system design. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Explain how to calculate voltage drop and how to minimize it by using larger conductors or shorter circuit lengths. Emphasize the need to keep voltage drop within acceptable limits to ensure that equipment operates properly and to prevent overheating of conductors. Provide examples of how voltage drop can affect the performance of different types of electrical equipment such as motors, lighting, and electronic devices. Also, discuss the importance of harmonics in electrical systems and how they can affect power quality. Harmonics are distortions in the voltage and current waveforms that can be caused by nonlinear loads such as electronic devices and variable frequency drives. Explain how harmonics can cause overheating of transformers, conductors, and other equipment, as well as interference with sensitive electronic devices. Describe the different methods for mitigating harmonics, such as using harmonic filters or line reactors. Emphasize the need to address harmonics in electrical systems to improve power quality and prevent equipment damage. Discuss the importance of power factor correction in electrical systems. Power factor is a measure of how efficiently electrical power is used. Explain how low power factor can increase energy costs and reduce the capacity of the electrical system. Describe the different methods for improving power factor, such as using power factor correction capacitors. Emphasize the need to maintain a high power factor to reduce energy costs and improve the performance of the electrical system. Remind the homeowner that electrical codes and regulations are constantly evolving, and it is important to stay up to date on the latest requirements. Advise them to consult with a qualified electrician or electrical inspector to ensure that their electrical system complies with all applicable codes and regulations. Encourage the homeowner to participate in continuing education courses or workshops to learn more about electrical safety and best practices. Explain that knowledge is the best defense against electrical hazards. Discuss the importance of documenting all changes and modifications made to the electrical system. Explain that accurate and up-to-date documentation is essential for troubleshooting and maintenance. Encourage the homeowner to keep a file containing all electrical permits, inspection reports, wiring diagrams, and equipment specifications. Advise them to provide this information to any electrician who performs work on their electrical system. Emphasize the importance of planning for future electrical needs when designing or modifying an electrical system. Encourage the homeowner to consider their long-term electrical requirements and to install sufficient capacity to accommodate future growth. Suggest installing extra conduit or wiring to make it easier to add new circuits or equipment in the future. Explain that proper planning can save time and money in the long run. Discuss the importance of protecting electrical equipment from environmental factors such as moisture, dust, and extreme temperatures. Explain that exposure to these elements can damage electrical equipment and reduce its lifespan. Suggest installing electrical equipment in enclosures that are rated for the appropriate environmental conditions. Emphasize the need to follow the manufacturer's recommendations for installation and maintenance of electrical equipment. By providing the homeowner with this comprehensive information, you can help them understand the complexities of their electrical system and make informed decisions about its operation and maintenance. This will help to ensure the safety and reliability of their electrical system for years to come. Remember to always prioritize safety and to consult with a qualified electrician if you have any questions or concerns.